Introduction to Cloud Computing, Services, Models, and Trends. Cloud computing has emerged as one of the most transformative technologies of the modern era, reshaping the way we store, access, and process data across countless industries. At its essence, cloud computing is a model for delivering information technology services where resources are provided as a service over the internet, rather than being hosted on local servers or personal computers. This model leverages remote data centers, scalable hardware, advanced networking, and virtualization technologies to offer a flexible, on-demand, and cost-effective alternative to traditional IT infrastructure. Over the past decade, the cloud has evolved from a niche concept into the backbone of modern digital transformation, enabling enterprises, small businesses, and individuals alike to innovate and compete on a global scale. The journey of cloud computing began with the idea of utility computing, where computing resources would be delivered as a metered service, much like how consumers use electricity or water. Today, although the concept has matured significantly, its foundational principles remain intact: resource pooling, rapid elasticity, and measured service. Resource pooling ensures that computing resources such as processing power, storage, and network bandwidth are dynamically allocated to multiple users based on demand, ensuring optimum utilization and efficiency. Rapid elasticity allows organizations to scale resources up or down almost instantly, enabling them to handle variable workloads without over-provisioning. Measured service, on the other hand, provides transparency by tracking usage for precise billing, which aligns costs with actual consumption. Together, these core tenets have democratized access to computing power by reducing the capital expenses traditionally associated with purchasing and maintaining physical infrastructure. Cloud services are typically organized into several distinct service models, each catering to different aspects of computing needs. The foundational model is Infrastructure as a Service, IaaS, which provides virtualized computing resources over the internet. IaaS allows users to rent virtual machines, storage, and networking components, thus eliminating the need for companies to invest heavily in physical hardware. This model is particularly appealing for organizations that require high levels of control over their computing environment and wish to deploy custom software stacks. IaaS providers maintain the physical infrastructure while clients are responsible for managing operating systems, applications, and data. Prominent examples of IaaS include Amazon Web Services, AWS, EC2, Microsoft Azure Virtual Machines, and Google Compute Engine. Building on IaaS, Platform as a Service, PaaS, introduces a higher level of abstraction by not only offering the underlying hardware but also an entire development and deployment environment. PaaS provides developers with frameworks, libraries, and tools necessary for building, testing, and deploying applications. By managing the back-end infrastructure, including servers, operating systems, and middleware, PaaS allows developers to focus solely on coding and innovation. This model accelerates application development, facilitates collaboration, and reduces the time to market for new products. Popular PaaS solutions include Google App Engine, Microsoft Azure App Service, and AWS Elastic Beanstalk. The next tier in the service model hierarchy is Software as a Service, SaaS, which delivers fully functional software applications over the internet on a subscription basis. SaaS eliminates the need for local installation and maintenance, offering users instant access to applications via web browsers. This model is particularly useful for end users and businesses that require scalable, ready-to-use solutions without the overhead of managing hardware or software updates. SaaS has revolutionized various industries by providing enterprise-grade applications such as customer relationship management, CRM, enterprise resource planning, ERP, collaboration tools, and more. Well-known SaaS products include Microsoft Office 365, Salesforce, Google Workspace, and Zoom. In addition to these core models, newer paradigms such as Function as a Service, FaaS, and serverless computing have gained popularity. These models take cloud abstraction even further by allowing developers to build and deploy individual functions or code snippets that execute in response to events, without requiring the provisioning of servers. This approach optimizes resource utilization and reduces operational overhead since scaling and resource management are handled automatically by the cloud provider. Serverless computing is particularly effective for variable workloads and microservices architectures, where demand can be unpredictable and highly dynamic. Cloud providers such as AWS Lambda, Azure Functions, and Google Cloud Functions have led the way in this innovative space. As cloud computing continues to evolve, several trends are shaping its future and influencing how organizations harness its power. One prominent trend is the widespread adoption of multi-cloud and hybrid cloud strategies. Instead of relying solely on a single cloud provider, many organizations are opting for multi-cloud deployments to mitigate risks, enhance flexibility, and avoid vendor lock-in. A hybrid cloud approach combines private cloud infrastructure with public cloud services, allowing businesses to maintain control over sensitive data while enjoying the scalability and agility of public cloud resources. This strategy is particularly appealing in regions with strict regulatory requirements or for sectors that handle highly confidential information. Another significant trend is the integration of artificial intelligence and machine learning into cloud platforms. Cloud providers are increasingly embedding AI capabilities into their services, enabling businesses to analyze large datasets, uncover insights, and automate routine tasks. AI-driven cloud solutions facilitate real-time data processing and provide advanced analytics tools that can predict trends, optimize operations, and enhance customer experiences. By integrating machine learning frameworks and leveraging vast computational resources, companies can deploy sophisticated models that deliver competitive advantages across various domains, including marketing, finance, and healthcare. Security and compliance remain critical aspects of cloud computing, given the sensitivity of the data stored and processed in the cloud. As organizations migrate more workloads to the cloud, ensuring robust security measures is paramount. Cloud providers invest heavily in state-of-the-art security protocols, including encryption, identity and access management, and advanced threat detection. Regulatory compliance is also a key focus, with providers working closely with their clients to adhere to data protection laws such as the General Data Protection Regulation, GDPR, and the Health Insurance Portability and Accountability Act, HIPAA. The continuous evolution of cybersecurity measures ensures that cloud environments remain resilient against cyber threats, enabling businesses to operate with confidence in a digital-first era. Edge computing is another trend transforming the cloud computing landscape. With the proliferation of the Internet of Things, IoT, and the exponential growth of data generated at the network's edge, processing data closer to its source has become essential. Edge computing reduces latency and bandwidth usage by performing preliminary data processing locally rather than transmitting huge data volumes to centralized cloud servers. This approach is particularly critical in applications requiring real-time responses, such as smart cities, autonomous vehicles, and industrial automation. By combining edge computing with centralized cloud analytics, organizations can achieve the best of both worlds: rapid processing at the edge and comprehensive data analysis in the cloud. In addition to these technological trends, the economic advantages provided by cloud computing continue to drive its adoption. The pay-as-you-go pricing model offered by CloudServices has lowered the barrier to entry for businesses of all sizes, enabling startups and small enterprises to access world-class infrastructure without substantial capital investments. This financial model not only optimizes operational costs, but also allows organizations to rapidly scale resources in response to demand fluctuations. The cost efficiency of cloud computing has been a key factor in its widespread adoption, encouraging companies to shift from capital expenditures to operating expenditures while promoting a culture of innovation and agility. Cloud computing is also fueling the shift towards remote and distributed work environments. With secure access to data and collaboration tools available from any location, businesses can tap into global talent pools, improve employee productivity, and maintain operational continuity amid disruptions. The flexibility afforded by cloud-based solutions has redefined workplace dynamics, empowering organizations to implement agile work models that prioritize connectivity and real-time communication. As remote work becomes increasingly prevalent, cloud computing will continue to provide the necessary infrastructure to support a globally connected workforce. The future of cloud computing is bright, with promising possibilities emerging on the horizon. Advances in quantum computing, although still in their early stages, are poised to complement and enhance cloud services by offering unprecedented computing power that can solve complex problems beyond the reach of classical computers. Researchers and innovators are exploring how quantum-augmented cloud systems might revolutionize industries such as pharmaceuticals, finance, and logistics by providing breakthrough capabilities in data analysis and simulation. Similarly, the ongoing integration of blockchain technology into cloud environments holds the potential to improve data integrity, traceability, and security, a combination that could drive new applications and use cases across various sectors. In summary, the evolution of cloud computing has been marked by significant advancements in service delivery, models, and trends that continually reshape digital infrastructure. The migration from traditional on-premises solutions to flexible, scalable cloud services has enabled organizations to achieve greater operational efficiency, cost savings, and innovation. Whether it is through the simplicity of SaaS, the customizability of IaaS, the developer-friendly environments of PaaS, or the emerging paradigms of serverless computing and edge computing, the cloud has fundamentally altered the way technology is deployed and utilized. As businesses embrace multi-cloud and hybrid cloud strategies, integrate artificial intelligence, and capitalize on the benefits of remote work, the cloud continues to be a key enabler for digital transformation. With future innovations on the horizon, including quantum computing and blockchain integration, cloud computing is set to remain at the forefront of technological progress, driving new paradigms of innovation, security, and efficiency across the globe.